Well, I can't say that because it's going to give away one of the questions in this low energy group. We're the mechanical energy group. Hi! Hey! And we're using these to see how far, and I can't say that either.
You can. How far what?
How far the piece will move, depending on the location.
Mr. Crosby, that's a wonderful view. We love it.
The important thing is we can see your guys' mother screen.
Okay. So that was funny. Sorry about that. So you're trying to see how far you can get this object to move.
Yeah, depending.
What is your variable? What are you changing?
The location of the fulcrum.
Okay, what is a fulcrum again?
The desk, the edge of the desk.
No, what's a fulcrum?
The thing that doesn't move.
In a
lever.
Okay, so you're using a lever to move an object.
Yes. Yeah, and I just gave away one of the questions on the sheet.
But you're using a lever to move an object, and you want to see if the place where the lever is affects how far the object's going to move.
Yes.
Okay. Everyone understand that? So my question in the Cover It Live, can one of you check this question? My question is, what is your prediction? Is it going to be when the lever makes the end where the checker is longer? Or is it going to be when it makes the end where the checker is shorter? What's your prediction? If we move the fulcrum closer to the object, will the object move farther away, or will it be closer? Make a prediction, everybody.
Somebody is...
Did you all do that? How do you write a prediction? What are the first two words? I predict, or I think, or my
prediction.
Hypothesis. We're scientists now. My hypothesis would be that the closer the fulcrum is to the object, the farther the object will go, or the less far the object will go.
Hi, camera.
Make a prediction.
10, 6, 4.
Okay, so we're ready to do the experiment. Where is the first place that the fulcrum's going to be?
The 10-inch line.
The 10-inch line. So Google Doc people, you need to get that in there. But only one of you needs to get it in there. So whoever gets it in first, no one else copy it over. But somebody, launch number 1 is 10 inches.
Somebody got it.
Oh, attempt number 1 is 10 inches. Okay, are we ready?
Yes.
How many of you predicted that the closer the fulcrum is to the object, the farther the object will go? How many of you, the closer the fulcrum is to the object, the farther the object will go? How many of you predicted that the fulcrum needs to be far away from the object? Okay, no one's making any predictions at all? Oh, so it seems like most of us are thinking that the farther away the fulcrum is from the object, the farther it will go.
Yeah.
So 10 inches is the farthest away it's going to be, correct?
Yep, yep.
Okay, 10 inches it is. Here we go. Wait, let me get really close.
And Garrick will be launching the piece. Tanya will be seeing where it lands first, and I will be recording the answer.
Okay, Garrick, hit it.
Right here, 14 inches.
14 inches.
First
Attempt
try at the
number
10-inch
one.
line.
14 inches. Make sure that gets into the Google Doc.
At the 10-inch line. Oh boy.
It's so hard to do it all at the same time.
It's so hard.
Everybody gives us that when they're not supposed to.
Okay, so what's the next one?
6 inch.
6 inches. How many of you think it's going to go farther? We're closer to the object now. How many of you think that object's going farther?
Oh my gosh. Something just happened. Someone just erased the whole thing.
Yes.
Yeah, what just happened?
Okay. It's back.
I lost it.
Oh, it's back.
I see.
Okay, whew. Little Google Doc problem there. Here we go at 6 inches, and Tanya, could you not get hit, please? Okay, go, Garrick.
We'll redo that.
Okay, redo. All Garrick did was hit himself in the head.
Okay, 11 inch
11 inches.
at the 6-inch line.
And then the words now.
Yeah.
Launch one.
Yeah, I'm trying to
launch
fix the words back.
two. Yeah, somebody deleted over launch.
Okay, everyone in the Google Doc, you can't delete the words that are already there. All you're doing is filling in numbers.
I'll fix it. Oh, I shall fix it.
Somebody's here. Raise your hand.
I already launched one here. Launch.
Only those two guys are typed in Google Doc.
Okay, now it's at the 4-inch line. I think. Is it?
I don't know. Tilt. Oh no.
We're gonna have to hold it. Okay, hold up. Let's put it at the
Okay, this is going to be hard. It's at what line?
At the 4-inch.
4-inch line.
Okay, hold up. Let me get ready. Hold up. Okay. Go. Launch. Where is it?
Didn't launch. Let's try that again.
They should mostly be looking at the cover of Live. And just
Yes.
occasionally glance back.
Yes.
And
Okay, it's interesting. We can't even get it to launch.
Okay, let me do it. Let me try. Get a new book. You try. Okay, I got it. Let go. Let go. Let go. Set. At the 13-inch line.
13 inches.
13-inch line?
Yep. So the results were
When we put it at the 10-inch line, we got 14 inches travel. And when we put the ruler at the 6-inch line, we got 11 inches. When we put it at the 4-inch line, we got 13 inches.
So what is that telling us?
That the closer to the object,
We don't know, do we?
no, because it's not how we planned.
So the question is, what should we do? Because we seem to have mixed information.
We thought
So-
that when it would be at the 4-inch line, it would be the shortest, and when we thought when it would be at the 6-inch line, it would be in the middle.
Okay, so I would like to try launching. Can I try
Sure.
launching?
At the 4-inch line.
So 10,
So redo.
here's the
Redo.
10-inch launch. Ready?
Hold up.
Where'd it go?
Where did it go?
It's on the pillow.
The pillow. Uh-oh.
And where is the pillow?
30 inches.
Okay, so 30 inches for
So
10.
30 inch plus 39 inches would be 69.
So 69 inches for 10 inch bar. What's the next one? 6 inches?
6 inch.
Here we go.
Okay, hold on.
I don't know how to launch.
Ready? Set. Okay, that was at 26.
27 inches for 6. So what's your prediction for 4?
We think it will be the lowest.
The lowest.
16 inches.
Again, we-
And it was 16 inches for 4.
What? What?
So we now have different results. Let me tell you what they were doing wrong. What I did differently. I made my fulcrum by the desk. I held my hand right by the desk. And you were holding it by the end of the ruler.
Yeah, so it had less.
Right. So the longer the distance between the object and the fulcrum,
The farther
the farther away the object will go. I hope someone put that in the Cover It Live. The longer the distance,
Everybody understand what happened there?
Yeah.
the longer the distance that between the fulcrum and the object, the farther the object will go. How many of you have seen a catapult?
Hey, look, if my finger is the fulcrum, and they were putting that thing they were launching here, the closer, the further the fulcrum was from the object, the further it went.
So remember the driver from golf? Wasn't that the longest club?
Yes.
And didn't that send the ball the farthest?
Yes.
Because the distance was the farthest. And if you've seen catapults before, like in old medieval movies, they're really long, aren't they? They're not like this tiny little thing. Pew. Really long.
Yeah.
If we want to throw a baseball, do we throw a baseball with our elbow tucked on our side and go? No, you want to use your whole arm. You want to actually stretch back before you throw it because you're making your distance even longer.